It's going to be recorded. So today we'll be looking at piping materials. Any facility, production facility, is just like the human body. In the human bodies, we have veins, we have the intestine, we have the blood. When you eat, how does the body get the food you eat? The various organs, the various systems. The blood actually transports the nutrients from your food to the various parts of your body. The food enters your mouth, goes through the passage, goes through the different ways. You have different passage ways to which the food passes through. The same thing actually occurs. The same thing occurs in any production facility. You can have a vessel, you can have an equipment. So let's assume you have a pump, and the pump right now is to deliver water to, let's say, a distillation unit. How would that occur? There needs to be a transport medium. This transport medium now actually constitutes your piping, the piping you're going to make use of. So piping is very, very important. It's very, very important. You can't transport materials without a piping system in place. And what are the materials that actually make up a piping system? What are the materials that makes up a piping system? That's what we'll be looking at. We have pipeline, we have piping. They are similar, but there is a little difference. So let me quickly share my screen. Yeah, in this picture I'm displaying right now, we have a distillation column. This is a distillation tower. This is a reboiler. A reboiler is a kind of heat exchanger. And these are pumps. We have two pumps here. Then materials are sent from the distillation column into the reboiler. And also, after the reboiler, what does it do? It's going to heat up whatever is sent into it. And the heated material as well is sent back into the distillation column. Okay. Then some materials, products are taken out from the bottoms of the distillation tower and sent to the pump. All this would not have been possible without piping. This would never have been possible. So quickly, I'm going to look at piping materials. Piping materials, one of them is a pipe itself, line pipe. In a facility, pipes are going to be referred to as line. You hear it, what line? Which line are you referring to? When they ask you which line are you referring to, they are actually referring to the size of pipe. Pipes comes in sizes 2-inch, 3-inch, 4-inch, 6-inch, 8-inch, 30-inch, 56-inch. So actually, when you hear the word line, it's actually describing the pipe size through which something is going to flow, or maybe it's already flowing. So the first piping material we're going to look at is the line pipe. So what are pipes? Pipes are actually tubular products of various sizes, and they have external diameter and internal diameter. Since they have both internal diameter and external diameter, that means they have a thickness. They have a wall thickness. They have what? A wall thickness. So they can be classified in schedules. They are normally manufactured in 6 or 12 meters length, either seam or seamless, depending on the sizes. Okay. Now, for example, now we have a seamless pipe, we have a roll pipe, we have a spiral web pipe. This category is based on how they are manufactured. For a seamless pipe is not going to have any line. It's not going to have any line. Unlike this row one that is rolled, it is rolled. You're going to see a line. But for the seamless, it's not going to have that line. While the spiral weld pipe looks like that container where they normally wrap tissue paper, toilet roll around. So, like I said, that this is the cross section of a pipe. This is the cross section of a pipe. This is the ID, the internal diameter. This is the OD, the outer diameter. So that means it has thickness. It has wall thickness. Now, basically, pipes are described in terms of schedules or schedules. US schedule 40 pipe, schedule 60 pipe. We can have a 10-inch pipe of different wall thickness. When you go to the market and tell them, I need a 10-inch pipe, they are going to ask you, what wall thickness, what schedule? What do they mean? What they are trying to tell you is that all 10-inch pipe are going to have the same outer diameter, but the internal diameter is going to vary depending on the schedule. You can have a schedule 20 pipe, a schedule 40 pipe, a schedule 80 pipe. The higher the schedule, the higher will be the thickness, and the smaller will be the internal diameter. But the outer diameter of all 10-inch pipe are going to be the same. But the schedule, the thickness will vary based on the schedule. So now the question is, why are the internal diameter different? Why do they have different schedule? Why are not all 10-inch pipe? Why don't they have the same internal diameter? The reason being that when you have a pipe are going to be used for different purposes, different fluids, different liquids, different gases, and different fluids, different gases, different liquids, they have different characteristics. There are fluids that will easily attack a pipe. There are fluids that will readily attack a pipe and cause a pipe to undergo corrosion. Different pipes, based on different materials they are made of, they will respond differently to environmental conditions like temperature, pressure, and the rest. Maybe the ambient condition, the whatever you have, the kind of soil it's going to be buried in, the kind of water in that environment, the kind of air. So the materials are going to pass through. If it's a material that can easily attack your pipe, you're not going to use a pipe with a small thickness. if you are dealing, like I said, if you are dealing with a material that can easily attack your this thing, your pipe, you will have to use a pipe that has a large thickness such that before the fluid that is flowing in can attack and get to the boundary, get to the outer layer, it will take time. You understand? So based on whatever fluid is going to flow, that will decide the thickness that is going to be used. Whatever that material is carrying also will decide the thickness. The environment in which the pipe will be laid will also determine the thickness. I hope I'm making sense to you this evening. I hope I'm making sense.
Very well. Very well.
Benga, you're welcome. Benga has just joined us. You're welcome. So the material is going to influence the thickness, the substance that is flowing. Is a corrosive substance. The environment also will also tell. You understand? So that's why pipes don't have the same wall thickness. And ideally, in any production facility, be it a refinery, be it a oil production facility, before they don't just go to buy pipe. They don't go to the market and just buy pipe. The design engineers, they have to size. First and foremost, they will size the internal diameter of that pipe that can do the job effectively. And when they are sizing, they are going to take the characteristics of the fluid that is flowing. They are going to size based on that. The pressure will be taken into consideration. A lot of factors, fluid viscosity will be taken into consideration when they are sizing. They have to size the pipe. After they've sized and gotten the appropriate internal diameter of that pipe, that will allow this fluid to flow effectively at a particular pressure. And the fluid will arrive at the destination at an expected pressure. The next thing is to do the wall thickness calculation. They will now do the calculation for the wall thickness of that pipe to actually find out the schedule of that pipe that is going to do the job. And another thing I want to let you know is that the fact that a pipe is 10 inch, a 10-inch pipe doesn't mean that the outer diameter will be 10 inch or that the inner diameter will be 10 inch. This 10 inch, when they tell you 10-inch pipe, this 10 inch is referring to the normal, what they call the nominal pipe size. The nominal pipe size, NPS, nominal diameter. Okay. Okay, I hope I'm making some sense. Okay. So quickly, there's something I want to quickly share. Okay, let me assume in a scenario whereby you have 3 tanks. You have this green tank, you have this purple tank here, and you have this yellow tank. These 3 tanks, and the green tank contains water. The purple tank contains water as well, but the yellow tank has no water, and the yellow tank is in an area where people are. They need water. This green tank and the purple tank is actually far away. So you have to supply water from the green tank to the yellow tank, water from the purple tank to the yellow tank, so that the people will have access to drinking water. The first thing that will come to your mind is, what am I going to use? What piping material am I going to use? So the first thing is that you are going to make use of what? You're going to make use of a pipe. So the next thing is for you to go and get your pipe. You go and get your pipe. So the first thing is that you will get your pipe. Now we've gotten our pipe. Having gotten our pipe, there is still a problem, because look at, we've connected a pipe to the green pipe. It stops here. A pipe to the purple tank. It stops there. And the destination tank, that is the yellow tank, where we intend to move the water to, we have pipes connected as well. This is a vertical one, horizontal, vertical again, horizontal. So, but there are gaps. There are gaps. There is a space between the pipe and the purple tank. There's a gap in between. There's also a gap between the pipe that needs to connect the green tank as well. There's also a gap between the pipe that needs to connect the yellow tank. Now, each of these tanks has what they call nozzle. These are the nozzles. A nozzle, any equipment through which something is going to enter or leave, must have what we call a nozzle. If not, how are you going to move it out? Nozzle can be entry point or exit point. But there's a challenge right now. There's a gap here. There's no how we'll connect these pipes together at this point, and things will be okay. Then also here, at this corner here, where we have this horizontal pipe and this vertical one, there's no how we can connect these 2 pipes properly together. Also here, there's a problem. Also here, there's a problem. Between this pipe and the nozzle, there's a problem. Between this pipe and the nozzle, there's a problem. There's a gap. So that is where, at this stage now, what are we going to do? How do we solve this problem? This problem can only be solved with the aid of what they call fittings. We've gotten the pipes. All the pipes that we need, we've gotten already. But still, there's no how. The pipes alone cannot do the job. We need connectors, what they call fittings. So at this stage now, I'm going to move to the next piping material, which is what they call elbow. Elbow. Okay, before I even talk about the elbow, what do fittings do? What's the job of a fitting? A fitting permits a change in direction, a change in diameter of pipe or branch to be made from the main run of pipe. So in the previous one we just saw right now, this pipe was moving. It needs to send water here. There's a change in direction. This one too was coming. It needs to connect with this one, connect with this one. This one needs to connect. There's also a change in direction with this one, with respect to this one as well. So we need a fitting here that will allow this pipe to connect to this one and to this one. Also, when this pipe came, this particular yellow pipe here is moving horizontally. Now there is a vertical change in direction. It's now moving vertically. So there is a fitting that we need to install at this point so as to permit that change in direction of the liquid, the water that will flow from here to this point. We need a fitting. We need a fitting there. Then also, if you're looking at this pipe, the pipe that connects to the yellow, to the purple tank, and the pipe that connects to the green tank are of the same size. They are what? Of the same size, but this one is smaller. The one that connects to the yellow tank is smaller. So how is it going to, if we mesh them together, that means there will be outflow of water because they will not be able to enter into one another. The yellow pipe will not be able to enter into these blue pipes, which are actually larger. So we need a connector. We need a fitting that will actually allow us to do that. We need a fitting that will allow us a change in diameter of pipe. We need a fitting that will help us accomplish that as well. So also, if you look at from this nozzle to this pipe, there's a gap. The pipe cannot lap properly into this nozzle. So we need another fitting that can actually enable that pipe to lap into this nozzle. And the same thing at all the nozzle here, as well as the nozzle here. So, like I said, fittings permit a change in direction, a change in diameter of pipe, or branch to be made from a main run of pipe. There are several types of fittings. The first fitting we're going to look at is called an elbow. What do elbow do? What is the job of an elbow? An elbow actually permits a 90-degree or a 45-degree change in direction of the run of pipe. If you want to change direction, either by 90 degree or 45, you need to introduce an elbow. You need to introduce an elbow. So in the next 10 minutes, the free version of this Zoom is going to end, but once it ends, just reconnect back. We're going to come back on board. So you need an elbow to accomplish that. So let me these are images of elbow. These are pictures of elbow. These are 90 degrees elbow. So the pipe can connect from one end and connect at the other end. These are 90 degrees elbow. Let me show you that of 45 degree. These ones are 45 degrees elbow. These are 45 degrees elbow. You have an elbow here. Then on this other end, we have a pipe connected to the elbow. We have another pipe connected to the other side of the elbow. This is a 45-degree elbow. So elbow make 90 degrees or 45 degrees changes in direction of the run of pipe. And we have long radius elbow with centerline radius of curvature. This is just grammar. You get to understand this with time. Equals to 1.5 times the nominal pipe size. Okay. So the elbow, we're going to go back to our diagram we showed before. So where are we going to need an elbow here? Where are we going to need an elbow? Where are we going to need an elbow? Yeah, this is an horizontal pipe. This is a vertical one. So the angle between horizontal and vertical is actually 90. So we're going to need an elbow to change the direction of flow here. We are also going to need an elbow here again. We are also going to need an elbow over here. So this is actually the blue pipes here. The two blue pipes are 6 inches, while the yellow pipe is 4 inches. So if I may ask, I want to ask a question. Any of you can answer, please. What kind of elbow are we going to introduce at this point? Yeah, and yeah. Is it 90 degrees or 45 degrees?
90 degrees.
90 degrees. You are correct. It's 90 degrees. It's actually 90 degrees. We're going to make use of a 90 degrees elbow. It's 90 degrees because the angle between horizontal and vertical here is 90. Angle between vertical and horizontal 90. Angle between horizontal and vertical is 90 over here. So we're going to need 90 degrees elbow. Okay, what is the size of that elbow in terms of inches? What will be the size?
4 inches or less.
4 inches, not less. It's going to be 4 inches. This is a 4 inches pipe. So the same size of elbow is what you're going to introduce. It is 4 inches pipe. So it's also going to be a 4 inches elbow. If let's assume if the pipe is schedule 40, the elbow also will be schedule 40 as well. Okay. So I hope that is taken. Now that is understood. I hope that is understood. Okay.
Yes, yeah.
Okay. So we're going to move on. So then there's what they call a bend. A bend actually does the work or similar to an elbow, but an elbow is more abrupt. The change in direction is more abrupt. An elbow allows a gradual change in direction. It might be at 90 degrees or 45 degrees. So a bend actually allows a gradual change in direction. So the next stuff we will be looking at is a reducer.
Calculated field. So let's come up with a formula that will tell us how many hours extra this employee worked.
We are going to be looking at a reducer. What's a reducer? Reducers are actually used to connect a large pipe to a smaller pipe or a small pipe to a larger one. That is the job of a reducer. And there are two types. We have concentric and eccentric. We have concentric reducers and eccentric reducers. We have concentric reducers and eccentric reducers. Okay. So let's quickly look at this thing. Look at the reducer. These are concentric reducers here. These are concentric reducers. These are concentric reducers. This was a concentric reducers. Okay. So let me show you eccentric. These are eccentric reducers. These are eccentric reducers. Okay. So going back to our figure. Remember, I told you that the blue pipes are actually larger than the yellow pipe. So that means before we can connect the yellow pipe to this one, we need a reducer. We need a reducer. And the blue pipe is actually 6 inch, while the yellow pipe is 4 inch. So the blue pipe is what? 6 inch, while the yellow pipe is a 4 inch. So Ujua, welcome. The blue pipe is 6 inch, while the yellow one is 4 inch. In less than a minute now, they're going to cut us off, but we're going to reconnect back. So the blue pipe is 6 inch, while the Ujua, please, you're welcome. Very soon they'll cut us off, but we're going to reconnect back. So get ready to reconnect back immediately they cut us off. You're welcome. So this blue pipe is 6 inch, while this yellow is 4 inches. But before you can connect these two pipes together, you need a reducer. It might be concentric, it might be eccentric. But since this is 6 inch and this is 4 inch, and flow is moving from here to here, you are going to need a